Okay, we're live again. So we go back to the calculator, right? So I'm going to change this back to what it was. Well, no, I'm going to change it to 3. I'm going to have a radius of 3, and I'm going to have my angle it's going to be 3 theta. So I want you to watch the little circle go around. It went around once, it went around twice, it went around twice. Wasn't that amazing? Do you want me to hang on to this? She's not here today. Yeah. Did y'all see it go around twice? Did it do that when it was 2 theta? No. Go back and change it. I want you to watch something. I'll fix it in a minute. Go in here and go this to 2 theta. 2 theta. Press graph. 1 time. Did you see it only circled around once? I need y'all to pay attention. You'll need to watch that. The reason I made you turn on that circle is because you could see it. Whenever it's an even theta, so if it's 2 theta, 4 theta, 6 theta, 8 theta, it will draw the complete thing between 0 and 2 pi. If it is odd, 3, 5, 7, 9 theta, it'll draw it twice. So it'll draw it completely once between 0 and pi, and then it'll draw it all again between pi and 2 pi. Do you understand what I'm saying? That's important if you ever take calculus. My calculus kids, I'm going to burn them on this because I'm going to teach them this, and they're not going to pay attention to me. And then when they get to they have to find the area of those regions. They have to they have to find the length of one petal. To draw one petal, they have to find that length, that arc length. In order to do that, they have to know when that petal is being drawn, and they don't. Y'all don't have to do that yet. That's ultimately why you learn this, is so that you can find out how long the path, this is a path of a particle, for instance, and you're finding how long the path is. Or you're finding it's some magnetic field and you're finding the area, the cross-sectional area of it. That kind of thing. But for right now, we just need to be able to recognize what they are. That's in radians. Radians is easy. I highly recommend it. Can you go between degrees and radians? So let me show you what I'm talking about. If we're here, if you're looking at degrees and radians, is it the same unit circle? Can you figure it out? So could you draw it in radians, and if they gave you a degree problem, could you convert it? Could you do the degrees if you had to? Right? Why? Because if you're going to do degrees, do you have to follow all these instructions? So go through it once on your own, see if you can do it. If you can't, is radian easy? Is degrees complicated, but you'll get the same graph? Okay? No. In fact, I'm leaving at 11 o'clock. My tutorials were Tuesday and Wednesday, like I said. Actually, they were Monday and Tuesday, excuse me. Monday and Tuesday this week. Yesterday and day before yesterday. All right. You got it? Everybody got it? That's all you're doing. You are literally plugging it in and looking at what the graph does. There are all kinds of graphs. So when you're doing this, do you have to sketch these? So all the ones that have the 2 theta, 3 theta, that kind of thing, they're making what's called a rose. Do you look at this? Is that the R? They are all, everybody look at the equation right here, highlight it. Right here. Every single equation is this one right here. It is, I lost it. You're graphing this, and every single time it's going to be some R is equal to something with theta. So you're going to get something where R is equal to a function of theta, and it's going to have a trig function in it every single time. And you're going to plug it in, and you're going to see what it does. But this is for the petals, that's the radius. For these, it's different. So just watch it draw it, and then sketch it. That's all I need to do is sketch them. When I say sketch them, okay, I got one more lesson to show you because it's about to go. So we're going to stop it. We're going to make a new one. Yeah, I know you're. You
keep on opening new tabs.
I don't mean to. I want to stop. I tried to press this.